In this video, we'll learn how to solve 1D kinematics problems for IB Physics SL. But before we start solving, I have 3 tips that'll help with making less mistakes and improving speed when solving. So the first one is always start off with drawing a picture for the problem because this will help you visualize what's going on. The second one is write all the known information from the problem in a chart. And the third one is identify which formula you need to solve the problem. So our first problem is a baseball is popped straight up. It's in the air for 7.25 seconds. How high did it go? So our first step is to just draw a simple picture of what's going on. So we could just draw a person standing on the ground. Then we could draw a baseball in the air. And then we could just draw position lines to just show the path that the ball takes. So it starts from the person's hand and then goes to the ground. And what we want to find is the height from the ground to the maximum point of the baseball. So that's all we need to draw for our picture. And our second step is to make a little chart of the known values that we have in the problem. So what I like to use is a given and wanted chart. It's kind of similar to a statement and reasoning chart from geometry. So you could just write G and W. And then G is the given, W is the wanted. So what we know from the problem is it was in the air for 7.25 seconds. So we could write that as TH. The H stands for hang time, which is basically the total time that it took for the ball to start from the person's hand to the point when it gets to the ground. So then the time that it takes for it to get to its maximum position would be half of that. So if we just take half of 7.25, we could write that as T rise, and that would be 3.625 seconds. And then that's all the information that's explicitly shown in the problem. But since we're on Earth and we're solving for problems on Earth, we know that the acceleration due to gravity would be 9.8 meters per second squared. And then we know that the ball starts from rest, so we could say that its initial velocity would be 0 meters per second. And then we could say that the position that it starts at is at 0 meters. So we could write SI equals 0 meters. And then what we want is the final position up here when it's at its maximum height. So we could write that as SF. Now we did our first 2 steps, and our second step is to find the right equation to use. This will take a little practice, so as you keep solving these problems, it'll be easier and easier to find the right equation to use. But for this problem, we can use the equation SF equals SI plus VIT plus 1 over 2 AT squared. So SF is final position, SI is initial position, VI is initial velocity, T is time, A is acceleration due to gravity, and T is time. So now we could start plugging in numbers. So SF is what we want, SI is 0, VI is 0. Now our time, this would actually be our rise time because we only want to find the maximum position of the ball. So we could use this value right here, T rise, 3.625 plus 1 over 2. Then A is 9.8 times the rise time, 3.625 squared. And then if we just solve for SF, SF would be 64.4 meters. I rounded that value off to 1 decimal point. So this is our final answer, 64.4 meters. And I want to highlight how easy it was to actually solve the problem once we made a picture and made the and made the chart. So that's something that's really important to do because it'll help with your accuracy and speed. So our next problem is the observation deck of a tall skyscraper is 330 meters above the street. How long would it take for a penny to free fall from the deck to the street below? So let's start off with drawing our picture. So we could just draw this for the observation deck. Then we could indicate that the height is 330 meters. And then we could just draw a penny with a circle. Then just draw some dashed lines for its motion. So that's our first step, drawing the picture. Our second step is drawing our table. So we know that the observation deck is 330 meters tall. So we could say that the penny starts from 0 meters and then ends up at 330 meters. So SI would be 0 meters and SF would be 330 meters. And remember that SI and SF indicate displacement. It's not distance. So it would make sense if it's displacement, since you can't travel 330 meters down for a distance. So then it starts at rest, so VI equals 0 meters per second. And then the acceleration due to gravity would be 9.8 meters per second squared. And what we need to find is the time. So for this problem, we could use the same equation as the first problem. SF equals SI plus VIT plus 1 over 2 AT squared. Now we could plug in numbers, so 330, then 0 for the initial displacement, then 0 for the velocity, then times time, plus 1 over 2 times 9.8 t squared. And then if we solve for the time, it would equal 8.2 seconds. So that's our answer for the second problem. So for question number 3, a bullet is moving at a speed of 367 meters per second when it embeds into a lump of moist clay. The bullet penetrates for a distance of 0.0521 meters. Determine the acceleration of the bullet while moving in the clay. So for our picture, we could draw the clay wall, and then we have a bullet that's moving like this. Then it embeds itself right here. Then this distance, we could say it's 0.0521 meters, and then we could just write 367 meters per second because that's its speed. Now we could write our chart for it, so G and W, and then we know the initial velocity is 367 meters per second. Its final velocity is 0 meters per second. Then its displacement when it hits the wall is 0.0521 meters. And we want to find the acceleration, and also our final velocity is 0 meters per second. So unlike the other two problems, the equation that we need to use for this problem